In this session, we're going to cover the financial semantic calculations available in Pyramid prequel language. Financial calculations often involve complex iterative logic that cannot be replicated manually through basic formulas. One of the reasons why you would want to do this type of calculation in Pyramid is because you can apply them against a large dataset directly that would be otherwise quite complicated and slow to do in something like Excel. In this demo, we're going to use a fake dataset of customers, their investment products, and the associated cash inflows and outflows over different dates to calculate the internal rate of return. Here, we can see investment product number 10 by customer C0, with all the cash movements in two metrics as well as a combined net cash metric over time. In this example, investment product number 10 produced a nominal $185,000 net gain for customer 0, while product 4 made a nominal $87,000 profit. For customer 2, product 9 made $240,000, while product 5 returned a $153,000 product for customer C1. And finally, product number 7 for customer 3 returned a loss of $12,000, which of course would produce a negative internal rate of return. The question is, how easy is it to create IRR for every product for every customer in Pyramid, and how much faster is it than doing it manually in Excel? To get a better sense of this exercise, we will start with a cross-tabulation in Pyramid of each product by each customer, showing their total net cash flows for each combination. Here, you can see it's quite easy to get a sense of what is profitable and by how much. But doing the same exercise for IRR would be more challenging. And to do that in Excel, you would need to look at a cross-tabulation of each customer by product, by every date with the net cash flow for each, in a gigantic grid much like this. And then you would add your IRR calculation into the spreadsheet cells. This might even work for something of a dataset of this size, but it would be horrific to do if there were tens of thousands of customers with thousands of investment products actively working across hundreds of individual dates. It would require a very large spreadsheet and might take forever to resolve, given the complexity of the calculations and iterations needed in IRR. By querying and resolving the logic against a large database directly, Pyramid provides a faster, more flexible, and scalable resolution to this exercise. To see how this works, we're going to start by creating a new formula against our investment data model. We will be using the XIRR financial formula in prequel semantic library, which calculates internal rate of return for an uneven range of dates. The first argument we need to provide is a list of dates for our cash flows. We can simply add a standard listing of all dates by picking the date attribute and every date element in its list. Next, we're going to need to supply a numeric value or data point. In this case, it's simply net cash flows. The other two optional arguments for the formula are providing a guess rate and a default rate in case the IRR logic does not resolve well. Next, we'll attach our formula as a new measure and then save it into the analytics catalog. Now, let's add it to our analysis in Discover. By adding the XIRR measure to the query, we can immediately see that the negative 2.31% internal rate of return for the P7 product is resolved, while for P10 it's a positive 16.02% and so forth. The IRR calculation changes based on the context of the product and the customer in the query. Where this could be better used is in our customer and product matrix, where we'll add the calculation in one hit and see the entire result set for the customer product combination. We can remove the net cash flows to simply look at the IRR per product for each customer, each accounting for its own net cash flows by each uneven date range, even though we cannot see it in the query. Now, let's create a variation of the solution. Let's duplicate our formula with a new name, and let's instead make it into a custom member for the date attribute. When we come back to our grid, let's remove the totals and the original XIRR measure. And now let's add the new XIRR calculation that is sitting in the data hierarchy, and this will add it to the bottom of our matrix. This produces the same return values, except it's in a slightly more convenient way of presenting it at the bottom of the grid. As I change the product, we can see the differences. So P15 for customer C15, we can see the rate of return at the bottom, and so on and so forth. This is typically how people look at IRR results in an Excel spreadsheet, except of course when I'm doing it in pyramid.